In this lesson 3.1.a, we will be working on our graphing skills. We will be graphing systems of equations. Our objectives are to graph systems of equations, to understand that the solution is the point of intersection, and to rewrite linear equations to y equals mx plus b form in order to graph. And remember, that form is called slope-intercept form. Some big essential understandings for you is to understand why we're doing this. A system of equations can be used to model problems, and we'll be exploring that in our next lesson. The systems of equations can also be solved in more than one way. One method is to graph each line and locate the intersection point, and that's what we'll be doing today. But there are other methods that we'll be doing in the future. So let's start off by solving a system of equations by graphing, and then what we're going to do is go back and check our solution. And this is always a good idea to determine if we in fact got the right solution. So we have two very basic equations set up already for us in slope-intercept form. We have y equals x plus 2, and we have y equals 3x minus 2. And notice that I went ahead and put in the slope for you and the y-intercept. So we can see that our slope is 1, since there's a 1 in front of the x, and a y-intercept of 2, and that's our number out here. In the second equation, the slope is 3, and the y-intercept is negative 2. So given to us like that, they're very easy to graph. So let's go ahead and graph these two equations. So in our first equation, we start at the y-intercept, so we place our point here at 2, and then we use our slope to help us figure out where the next point is. Well, our slope is positive 1 over 1, so we would go up 1 and over 1. We could also go down 1 and over 1, as long as our line is sloping in the positive direction. And that's a big thing to keep track of. People often forget that. And then we can draw our line. Okay, let's look at our next line. Our y-intercept is at negative 2. So that's down here. We start always at our y-intercept. And then from that point, let's do a different color. From that y-intercept point, then we always find the second point using our slope. There's our negative 2. And our slope is a positive 3 over 1. So I'm going to go up 1, 2, 3 over 1. I can also go down 1, 2, 3, and over 1 if I choose. Again, as long as the line is sloping in a positive direction. And maybe I'll do one more. 1, 2, 3 over 1. And right now I can see, without drawing a line, where my two lines are going to intersect. Let's go ahead and draw our line. Okay, and now we have our two lines. We can find the point of intersection, and that is the one point where the two graphs are going to equal each other. And so this point right here, make a dot, is our solution to our systems of equations. And that point, you can see it's over 2 and up 4. So the solution to our systems of equations is 2, 4. So let's go ahead and check and see if those are in fact the correct solutions. Sometimes when we graph, it's hard to draw a straight line or make sure that you have the right point. So we're going to go ahead and check it. So in our first equation here, we'll plug in a 4 for our y, and then we'll plug in a 2 for the x. So what we're looking for is that the left side equals the right side. And if we notice, 4 does in fact equal 4, so it checks off with that one. Now let's check the bottom one. So we'll plug in a 4 for y, plug in our 2 for our x, and then let's simplify. So we have 4 on the left side. 3 times 2 is 6, and 6 minus 2 is 4. So as you can see, this point 2, 4 works in both of these equations. We solved it by graphing, and then we checked our solution. All right, let's try a little bit more difficult example. In this example, you can see that the top equation is not in the y equals mx plus b form, so we would want to rewrite it to be in that form. Okay, so let's write this equation down here, and then let's go ahead and rewrite it. So what we know is that we want y to be by itself on the left side. So I'm going to move the x over to the other side by adding x. On the left side now, I'm just left with my 2y, and on the right side, I'm going to have x plus 2. Finally, I'm going to divide every term by 2. 2 divided by 2 is 1 or 1y. And then x divided by 2 is the same as 1 over 2x. 2 divided by 2 is 1. So now I have my equation, and you can see that my slope is 1/2, and my y-intercept is 1. So we'll go ahead and graph this one. Here's my y-intercept, which is 1. My slope is up 1 over 2 in the positive direction, and then I can make my line. Okay, let's work on the second equation. So our second equation is y equals 1/2 x plus 1. So if I look at this equation, my y-intercept is at 1. Which is right here. Same place my other one was. My slope is the same. It's up 1 and over 2. So look what we have here. We have two lines that are on top of each other. We know that when this happens, we have the same line, and we have an infinite number of solutions. So that means any point on this line will work in any of these equations. So let's try one out, just so that you can see. Let's go ahead and pick, we'll pick this point here, how about? And this point is 4, 3. So if we take this point and plug it into both of these equations, it should work. So let's do a quick check. So in our first equation, we have 2. We'll plug in the 3 for y. Minus 4 equals 2. 3 times 2 is 6. 6 minus 4 is 2. Definitely works in the first equation. Let's go ahead and look at the second equation. So for y, we'll plug in 3 equals 1/2 times 4 is our x plus 1. So we get 3 equals 1/2 times 4 is 2, and 2 plus 1 is 3. So 3 equals 3. It works in the second one. In fact, any point on this line will work in both. So that is why we have an infinite number of solutions. We definitely have more than one solution. We have an infinite number. All right, let's try a third example. So in this example, again, it looks like we will need to rewrite our equations. So let's go ahead. We're going to need to rewrite both of them. So let's number these 1 and 2. So let's start off with equation number 1. We have 3x plus 2y equals 1. I'm going to move the 3x to the other side. Okay. And I'm left with 2y equals negative 3x plus 1. And then I just need to divide every term by 2. And my final equation will be y, because 2 divided by 2 is just 1y, equals, I can't divide negative 3 over 2, so I'll just leave that, plus 1/2. I can't divide that either. Well, I can, but then I'll end up with a decimal, and it'll be easier to graph it like that. Okay, so that's equation number 1. Let's look at equation number 2. In equation number 2, we have 4y equals 6x plus 2. All we need to do is move the 4 to the other side. So we will divide each term by 4. 4 divided by 4 cancels, and we're left with y. I'm going to go ahead and reduce 6 over 4, and 2 goes into 6 3 times, goes into 4 2 times. 2 divided by 4 is 1/2. Okay, so what I'm noticing here right now is that we have the same y-intercepts. So let's see what happens when we graph this. So let's go ahead and graph the second equation. So our y-intercept is at 1/2, so that's about right here. And then our rise is 3 and our run is 2. So let's go up 1, 2, 3, and over 2 and make a point. Now if we go ahead and draw our line, okay, now we have our line. Let's go ahead and graph our first equation. So we know that in our first equation, our y-intercept is the same. So there it is, 1/2, but our slope is -3/2. So I'm still going to go up 1, 2, 3, but then I'm going to go over 2. And now we'll go ahead and draw the line here. Okay, so now we have our two lines. We can see that just because they have the same y-intercept doesn't mean they're parallel, doesn't mean they're the same line. In fact, the y-intercept ends up being our solution. So if we write our solution down, our solution is 0, 1/2. All right, and if we wanted to check our solutions, we could definitely check our solutions by plugging them back in. So let's go ahead and do that. So in our first equation here, if x is 0, we would plug it in like this. 3 times 0 plus 2 times 1/2 equals 1. 3 times 0 is gone. 2 times 1/2 is the same thing as 2 over 2, which is just 1. And 1 equals 1. That one checks out. Now let's go to our second equation here. In our second equation, we will have 4 times y, which is 1/2, equals 6 times 0 plus 2. 4 times 1/2 is the same as 4 over 2, and 4 over 2 is 2. 6 times 0 is 0, and that leaves us with 2. So that checks out for the second one as well. And that's how we check our solutions. Okay, moving on. Let's try one more. So in this one, we have, again, both equations that we will have to go into and rewrite in the y equals mx plus b form. And when we're done with this, I'm going to show you what your practice will look like. Your practice will be in Khan Academy, and you'll have some problems like this that you'll have to rewrite, and you'll have some problems that are already in y equals mx plus b form. But I wanted to show you how to graph in Khan Academy. So once we go ahead and solve this, then we'll go over to Khan Academy and I will show you how that works. So here's our first equation, and we know that we need to solve for y. So we're going to move our x term to the other side. So we're going to add 12x. Now remember that we cannot combine these two on the end because they are not like terms. So we are left with 8y equals, and I'll put the 12x first. As long as I keep the signs with the respective term, it'll be okay. I now need to divide every term by 8 in order to solve for y. 8 divided by 8 cancels, and I'm left with y equals, I'm going to reduce this. 4 goes into 12 3 times. 4 goes into 8 2 times, and I reduce that so that it's easier to graph. 24 divided by 8 is 3. And notice that I brought down the negative sign, so I didn't forget that. So that's going to be our first equation. Now let's jump to our second equation. So in this one, we have 4x minus 8y equals -8. I'm going to subtract 4x this time to move it to the other side. And I'm left with a -8y equals a -4x. And notice that I kept the negative with the 4x. And then I'm going to keep the minus with the 8. Okay, and the final thing I need to do is divide by a -8. And make sure that you divide every term by the -8. So on the left, we are left with just 1y. Negative divided by negative is a +1. And then on the right, a -4 and a -8 reduced down to 1 over 2x. And a negative divided by a negative becomes a +1. -8 divided by -8 is +1. So now we have our answers. Let's go graph those in Khan Academy. Okay, So I've realigned this so you can see the Khan Academy practice here on the right. When you click on the link, you'll get to this types of practice, and we'll compare it to what we just did. These are the same equations, negative 12x plus 8y equals negative 24, and 4x minus 8y equals negative 8. And we went ahead on our own, which is what you would do on your paper, and we rewrote it in y equals mx plus b form. So let's graph this first equation. So our y-intercept is negative 3. So I'm going to use this green line down here, and I'm going to pick one of these points, and I'm going to put it on my y-intercept. So I'm going to grab it, and I'm going to move it to the y-intercept. Now my slope over here says 3 over 2, and it's positive. So that means I'm going to grab the other point, and I'm going to start here at the y-intercept, and I'm going to go up 1, 2, 3, and over 1, 2. Okay, and my line is in the positive direction, and I'll verify what I just did. I went up 1, 2, 3, over 1, 2, and I look to be in a good shape. Okay, let's go to our second line down here. We found the y-intercept to be positive 1. So again, I'm going to grab either the left or the right one. It doesn't matter. Actually, I'll go ahead and grab the left one and put it here at positive 1. Then our slope is up 1 over 2. So I'll grab the other dot and go up 1 over 2. And now I can see my intersection point right here. The coordinates of that, and remember you need to list the x first, so you go over 4 for x and up 3 for y. So if I put a 4 in here for x and a 3 in here for y, if I check my answer, I should get a smiley face, and I did. So I'm in great shape. Remember that you have hints, and remember that there is a video available if you need a little more help solving the systems of equations.